Hi, this is hashtag math again. This is the last of the first differentiation rules. The remaining one is going to be the chain rule. And let's see how it looks like. So here it is, but it looks long, but it's easy to remember. Let's see how you remember the quotient rule. This function here I'm going to call high. The one in the denominator I'm going to call low. So you start low, you go low, d high, minus, then you go high, d low, square the bottom, and away we go. Easy to remember. Let's apply the quotient rule in this first example. We want to find the derivative of the function h of x, and we just apply our rule. So we start low, which is the denominator, low, and then we derive the upper one, so low d high minus high, which is x squared, d low, square the bottom, and away we go. Easy. Now let's derive and do our little algebra and we'll be done. So this is 1 minus x cubed, and the derivative of x squared is 2x minus x squared, and now we derive 1 minus x cubed. The derivative of 1 is 0, so we don't write it. This is negative 3x squared all over 1 minus x cubed squared. You do not distribute the denominator, you do not do anything. You keep your powers there. And then this is equal, I'm going to distribute the 2x, so this is 2x minus 2x to the fourth power plus 3x to the fourth power all over 1 minus x cubed squared. Then I combine these two numbers, and the derivative is x to the fourth power plus 2x over 1 minus x cubed squared. Here is our second example. I'm going to use prime notation. The derivative of h, I'm going to leave the 4 all the time in the front, and I'm going to derive square root of x over x squared minus 2. So this is what we're going to derive. And we proceed with the quotient rule. Keep the 4, and we do low d high minus high d low square the bottom, and away we go. Okay, now let's derive. We keep the 4, so this is 4 times x squared minus 2, and then the derivative of root x, as we've seen, is 1 over 2 root x minus root x, and the derivative of x squared minus 2 is 2x all over x squared minus 2 squared. And then this is 4 times, and we want to make the numerator have a common denominator, and that common denominator is 2 square root of x. For that, I will have to multiply and divide 2 root x over 2 root x to this term, and in that way we get a common denominator of 2 root x. For the first term we get x squared minus 2, and then minus. In the second term we multiply 2 times 2 is going to be 4. Root x times root x is x, times this x here is x squared. Okay, so this is 4 times, now we combine, negative 3x squared minus 2 over 2 root x all over x squared minus 2 squared. And we have a complex fraction. Remember how you do complex fractions? Let's keep the 4 there. You keep the numerator, minus 2 over 2 root x, and multiply by the reciprocal of the denominator, which is 1 over x squared minus 2 squared, and we multiply the fractions, so this is 4 times negative 3x squared minus 2 over 2 root x squared minus 2 squared. Now this 2 cancels out with a 2 here, and I'm going to distribute the 2 inside to make it nicer. So, and the negative sign I'm going to put on the front. So this is 6x squared plus 4 all over square root of x times x squared minus 2 squared. And that is my derivative. Okay, as I said before, how do you leave your answer? This is the way you leave it, because you always think that you might be needing to equal your derivative to 0 to find horizontal tangents. Look, if you equal all of this to 0, it's easy because a fraction is 0 only when the numerator is 0. So this is going to be 0 when 6x squared plus 4 equals 0. That means 6x squared equals negative 4, or x squared equals negative 4 over 6, or x squared equals negative 2/3. And what does this mean is that the solutions are complex solutions, meaning that this graph mustn't have horizontal tangents. Okay, let's look at the graph. Here you go. This is the graph of our original function, h of x. There you see the derivative, and you see that the only solution is a complex solution. So we don't have horizontal tangents. A horizontal tangent would look like this horizontal red line, and you go over the entire graph, and it is not tangent at any point to that graph. Okay, let's work our last example. Let's go and straight use the quotient rule. The derivative of h is going to be low x squared plus x plus 1 d high minus high d low square the denominator, and away we go. Let's do the derivatives. X squared plus x plus 1 stays the same, and we derive e to the x minus x squared. Derivative of e to the x is e to the x. Derivative of x squared is 2x. In the next term, we keep e to the x minus x squared. And the derivative of x squared plus x plus 1, is 2x plus 1 over x squared plus x plus 1 squared. At this point, I would tell you try to find a common factor, but the problem doesn't have that. So we have to make the big computation. So let's distribute. This is going to be x squared e to the x. I'll put my line first. X squared e to the x minus 2x cubed plus x e to the x minus 2x squared plus e to the x minus 2x. And then we have to distribute here. I'm going to keep the negative sign even if I have to write more, but we don't want to make mistakes with the signs. So this is 2x e to the x plus e to the x minus 2x cubed minus x squared all over x squared plus x plus 1 squared. And then we change the signs and combine. That's x squared e to the x minus 2x cubed plus x e to the x minus 2x squared plus e to the x minus 2x, and change the signs. Negative 2x e to the x minus e to the x plus 2x cubed plus x squared. Okay. Over x squared plus x plus 1 squared. And let's combine. Let's find what's similar and combine. So x squared e to the x, I don't see any other one there. X squared e to the x, so keep that one. X squared e to the x. We're done with this one. X cubed, there's another x cubed there, so they cancel out. x cubed and 2x cubed, they're the same. Then x e to the x. Do you see any other x e to the x here? So we combine this two. Negative x e to the x. Negative 2x squared can be combined with x squared here minus x squared. Then e to the x and negative e to the x cancel out. And the remaining one is negative 2x. X squared plus x plus 1 squared. And that's it. Thank you.